Welcome my dear friends, this is again your Virat Kumar, lecturer in electrical and electronics engineering. Yesterday we have seen about projection of points from the orthographic projections. I hope you have understood very well. You have gone through all the examples which I have given you in the yesterday session. So today in this session we will see about the projection of lines. So once again I welcome you all. A very good morning to you all. So projections of straight lines. So the information regarding a line means its length, position of its ends with HP and VP, its inclination with HP and VP will be given. See, information regarding a line means its length, position of its ends with HP. HP means horizontal plane and vertical plane, as I said you in the yesterday session. Its length, position of its ends with HP and VP, its inclinations with HP and VP will be given. And the aim is to draw its projections, means front view and top view. So there are some simple cases of the line, that is, number 1, a vertical line where the line is perpendicular to both HP, a vertical line where the line perpendicular to HP and parallel to VP. This is the first case. The second case is line parallel to both HP and VP, horizontal plane and vertical plane. The third one is line inclined to horizontal plane and parallel to vertical plane. The fourth one is line inclined to vertical plane and parallel to horizontal plane. The last fifth one, line inclined to both horizontal plane and as well as vertical plane. So these are some simple cases of the lines. So the study illustrations given on next page showing clearly the nature of FV and top TV, where FV is front view and TV is top view of lines listed above, and note the results. So there is a best animation I have just given to you in the next slides. So for all these simple cases of the line, so we will see one by one. What is the first one? A line perpendicular to HP and parallel to VP. Firstly, we will see the pictorial presentation. So as you know, this is a vertical plane and this is your horizontal plane. So there is a center with XY axis line. So now we are placing a line. The red colored one is your line, so which is perpendicular to HP. You can see that it is perpendicular to HP. It is perpendicular to HP and parallel to, it is perpendicular to HP and parallel to your VP. So we need to make the projections of this line and need to draw top view, front view and top view. So we know that observer is looking from here. So the top view will be on VP and the top front view will be on your VP and the top view will be on your HP. So all these diagrams are made in first quadrant. So that is called a first angle projection. As I have said in yesterday's class, we in our India choose to draw the pictorial diagrams or orthographic projections in first quadrant, which is called first angle projection. So you can see the line is called as AB, it's capital A and capital B. So observer, the arrow mark shows you the observer, which is front view, gives on vertical plane. That is A dash and B dash. That is your front view. Now top view, from the top view will be seen on HP, nothing but horizontal plane. It looks like a dot, both A and B on a similar dot, so this is called AB. So this will be your pictorial presentation. Is it clear? So now we will move on to the second diagram. So where a line parallel to HP and parallel to VP. So there is a line AB which is parallel to both HP and as well as to VP. How the pictorial presentation looks, we will just see it. Same VP and HP. So this is an AB line which is placed in such a way that it is parallel to both VP and HP. Similarly, the observer front view is projected on, the front view is projected on vertical plane, which is A dash and B dash, and the top view is observed on horizontal plane, similarly AB. So these are the projections. So this is the a line parallel to HP and parallel to VP. We will see the orthographic patterns, nothing but separately the front view and top view. So this is your front view and top view, you can see. So when this horizontal plane is turned in clockwise direction to 90 degrees, so then it looks in this way. Sorry. See the front view and the top view. Similarly for the second diagram, see here you can see front view is a vertical line showing true length and top view is a point. Now this is the orthographic pattern for second simple method for lines. Second simple case for a straight line. So in this also same, this is turned into 90 degrees towards clockwise, so then it looks in this order: front view on VP, top view on HP. Just note it down, take a minute, take a couple of minutes and make a note of these. So this is the orthographic patterns. Now we will move on to the next slide. So you can observe here from the note, front view and top view both are parallel to XY and both shown with the true length. What here is true length. The third simple case, a line inclined to HP and parallel to VP. We will see the pictorial presentation. VP and HP. So, we have placed a line in such a way that it is inclined to horizontal plane and parallel to VP. Now, the projections, the line is called AB, the front view is inclined to HP at an angle of theta, and the front view is projected on VP with A dash and B dash, and the top view is projected on HP, which is AB. So, here you can observe that the top view may not be the true length, since it is inclined, and by the projections you can clearly see that it is not in a order of true length. So, this will be your pictorial presentation, and this is your orthographic projections. See, you can see the front view is on VP and the top view is on HP. So, the actual length will be seen in your front view, but not in your top view. So, front view inclined to XY and top view parallel to XY. We will see the fourth case. A line inclined to VP and parallel to HP. Now, it is just reverse. Now, it is inclined to VP and parallel to HP. We will see the pictorial presentation. We have both vertical plane and horizontal plane with an XY axis line. Now, here you can see that we have placed line AB in such a way that it is inclined to VP and parallel to HP. So, it is inclined to VP at an angle of theta. This is the top view will be on horizontal plane, which will be in the true length of AB. The front view will be on vertical plane, which may not be your true length, with A dash B dash, and its orthographic projection is shown in the right side of your figure. See, the top view is observed in horizontal plane, which is inclined to VP. Inclined to VP is observed in HP, and parallel to HP is observed in VP. So, this is your third case, and this is your first case. See here, top view inclined to XY, front view parallel to XY. So, take a couple of minutes and make a note of that. Or else I will show the animation again. Just see the animation, how the thing was done. This is your orthographic projection. In the fourth case, a line inclined to VP and parallel to HP. This is your orthographic projection for fourth case. So, take a couple of minutes and make a note of the third case and your fourth case. Okay, now we'll move on to the next slide. This is your last case, which is fifth case. It is telling you that a line inclined to both HP and VP, a line inclined to both HP and VP. We'll see the pictorial presentation with VP and HP and with the center XY axis line. See, we have placed an AB line in such a way that it is inclined to both HP and as well as to VP. Similarly, front view on HP, front view on VP and top view on HP. See, the line is inclined to HP at an angle of alpha, which is projected on VP, and the line inclined to VP at an angle beta, which is projected on HP. So this is your pictorial presentation. See, this will be your pictorial presentation. When this is turned to 90 degrees in clockwise direction, see here, you can see that was your actual diagram. We just took off the center line. See that. So this will be your original one. So on removing the object, the line AB, the front view has an image on VP, the top view has an image on HP, and when it is turned to 90 degrees, it looks in this order, and it looks in this order. So take a minute to make this diagram, or else I will show it again. See the illustration carefully. When this had turned to 90 degrees in clockwise direction, it looks in this order. So make a note of that. Okay, we will move on to the next slide. So before that, he is saying that orthographic projections. So F is seen on VP clearly. To see TV clearly, HP is rotated 90 degrees downwards, hence it comes below XY line. So note these facts that both front view and top view are inclined to XY. No view is parallel to XY, but both front view and top view are reduced lengths. So no view shows you the true length. So this will be a actual diagram. So where orthographic projections means front view and top view of line AB are shown below with their apparent inclinations. See where the front view, see it is inclined at an angle of alpha to HP and inclined at an angle of beta to VP. So here top view AB is not parallel to XY line, hence its corresponding front view AB is not showing true length and true inclination with HP. Similarly, note the procedure when front view and top view known, how to find true length the views are rotated to determine true length and its inclination with HP and VP. So firstly we need to draw the true length at an angle of alpha, the inclination, is drawn. So in this case top view is rotated and made parallel to XY line, hence its corresponding front view A dash B1 dash is showing true length and true inclination with HP. Now also note the procedure when true length is known, how to locate front view and top view. Component A dash 1 of true length is drawn with its further rotated to determine front view. So this is your exact inclined to both the planes. So here A dash 1 is A to 1 is component of true length. A B1 gives length of front view, hence it is brought up to locus of A dash and further rotated to get point B dash. A dash B dash will be front view. Similarly, drawing component of other true length a dash b 1 dash. So, top view can be drawn. Just analyze the diagrams. Okay, we will move on to the next slide. So, the last diagram in the above in previous this. So, this diagram is over here. He is telling you all the indications in it, that the most important diagram showing graphical representations among all important parameters of this topic. So, study and memorize it as a circuit diagram and use in solving various problems. So, here you can see the line AB, which is parallel to both, or which is inclined to both vertical plane and horizontal plane. So, there are some illustrations given in this. The true length a dash b 1 dash and AB, a dash b 1 dash and a p. Angle of true length with HP is theta, angle of true length with VP is pi, and angle of front view with XY is alpha, and angle of top view with XY is beta. Length of LTV is length of top view, nothing but length of front view, which is component a to 1. So, length of front view nothing but length of top view, which is component of a dash and 1 dash. Position of A, distances of A and A dash from XY. Position of B, distances of B and B dash from XY. 10th one, distance between end projectors. So, you can see that, note this, theta and alpha construct with a dash, pi and beta construct with a b dash and b 1 dash on same locus, b and b 1 on same locus. And you also remember that true length is never rotated, its horizontal component is drawn and it is further rotated to locate view. So, views are always rotated, made horizontal and further extended to locate true length for theta and pi. So, the above 10 are important 10 parameters to be remembered with notations used here onwards. So, these in group A you can see the general cases of the line inclined to both HP and VP based on these 10 parameters. So, here we are solving some problems. So, there is a problem number 1. So, line AB is 75 mm long and it is 30 degrees and 40 degrees inclined to HP and VP respectively, and A is 12 mm above HP and 10 mm in front of VP. So, draw the projections. A line is in first quadrant. Okay. So, now we will make the diagram. So, here we need to observe one thing, that line AB is 75 mm long and it is 30 degrees and 40 degrees inclined to HP and VP. So, this 30 degrees should be drawn in VP and 40 degrees should be drawn in HP. See, there are some simple steps to draw the figure, orthographic figure directly. First, draw XY line and one projector. See, this is draw XY line and one projector. Okay. Now, locate A dash 12 mm above XY line and 10 mm below XY line. Since he is saying that end A is 12 mm above HP, should be drawn in VP, and 10 mm in front of VP should be drawn below XY axis line. So, the second case is this way. Okay. So, this will be your VP and this will be your HP. Okay. Now, take 30 degrees angle from A dash. As I have said you, 30 degrees should be in VP and 40 degrees in HP. So, take 30 degrees angle from A dash and 40 degrees from A and mark true length. Therefore, 75 mm on both lines. Name these points as B1 dash and B1. So, this is a normal line. So, this is an inclined line which is of true length of 75 mm long. It is an angle of theta which is 30 degrees angle, and here it is 40 degrees angle of true length is 75 mm with pi, that is B1. Now, join points with A dash and A respectively. Now, draw horizontal lines locus from both points. See, these are the horizontal lines locus of both points. Now, draw horizontal components of true length A B1 from point B1 and name it 1. The length A to 1 gives length of front view, as we have seen already. Now, extend it up to locus of A dash, extend it up to locus of A dash and rotate A dash as center, locate B dash as shown. Join A dash B dash as front view. So, this will be your B dash, and join A dash and B dash in the blue colored, which is your original inclination. Now, similarly, from B dash, drop a projector downward and get point B. Join A and B, which is your top view. Did you got the point or not? So, let us show you again. This is very important one. Draw axis line X Y. Just see the illustration or the animation. Is it clear? So, just take a minute and make the diagram clearly and neatly in your observation notes. Okay, we'll move to the next slide. Problem number 2. Line AB 75 mm long makes 45 degrees inclination to VP, while its front view makes 55 degrees, and A is 10 mm above HP and 15 mm in front of VP. If line is in first quadrant, draw its positions and find its inclination with HP. Okay, these are some steps given. Firstly, draw XY line. Draw one projector for A dash and A. Locate A dash 10 mm above XY and top view A 15 mm below XY. Draw a line 45 degrees inclined to XY from point A and cut true length 75 mm on it and name that point B1. Draw locus from point B1. Now take 55 degrees angle from A dash for front view above XY line, which is of your true inclination, and draw a vertical line from B1 up to locus of A and name it 1. It is horizontal component of true length and is large front view, length of front view. See H1. So this is your length of front view. Continue to locus of A dash and rotate upwards up to the line of front view and name it B dash. This A dash B dash line is front view. Now drop a projector from B dash and locus from point B1 and name intersection point B. Now join line AB is top view of line AB. Now draw locus from B dash and from A dash. Draw locus from B dash and from A dash. With true length distance cut point B1 dash. Join A dash B1 dash as true length and measure its angles at A dash. Join A dash B1 dash, see this one, as true length and measure its angle at A dash. It will be the true angle of line with HP. So this will be your angle. So we need to measure it with your compass or protractor. So then that is your required angle. Is it clear? Okay, we'll see the next problem. Problem number 3. Front view of line AB is 50 degrees inclined to XY and measures 55 mm long, while its top view is 60 degrees inclined to XY line. If end A is 10 mm above HP and 15 mm in front of VP, draw its projections, find true length, inclination of line with HP and VP. Draw xy line and one projector. Locate A dash 10 mm above xy and 15 mm below xy. Draw locus from these points. Now draw front view 50 degrees to xy from A dash and mark B dash cutting 55 mm on it. Similarly, draw top view 60 degrees to xy from A and draw projector from B dash and locate point B and join AB. Then rotating views as shown. Locate true lengths AB1 and A dash B1 dash. And their angles with HP and VP. This will be a beta, theta and pi. Is it clear? I'll see it again. See the illustration, nothing but the animation. This is your pi. Okay guys, so this is up to your today's session. So tomorrow we will see the problem number 4. So I hope you have gone through all the things very well. So thank you for today's session. Thank you. Thank you one and all. Have a nice day.